All right, 1.4 is talking about trig functions at any angle, because we've mainly been talking about quadrant 1, mainly. I mean, on your notes on 1.1, we actually looked at the unit circle, we looked at all the quadrants, and we said, what was positive in quadrant 1 and quadrant 2 and 3 and 4. All those charts were on there. So what we want to look at today is focus mainly on the other quadrants. We know quadrant 1, everything's positive. To get to quadrant 1, you're doing a positive right and a positive up, so we know that. But if we have negative 3, 4 as our coordinates, that is not in quadrant 1. That's actually in quadrant 2. So if we go over negative 3 and we go up 4, this would be our angle. And if we always start at 0, we would have an obtuse angle. And wait a second, we can't have an obtuse angle in a right triangle. We need a right triangle to find the sine, the cosine, and the tan. So when it's not in the quadrant 1 where we can just drop a line straight down and make a right triangle, if it's in quadrants 2, 3, or 4, then you're still going to drop a line straight down just in that specific quadrant because you need the right angle. So this is now going to be my right angle. We're going to call it theta prime. It's actually called a reference angle, and it's going to be the one new concept that we're going to talk about today. It's called a reference angle. And a reference angle makes a right triangle in any quadrant. We got to find out where the right triangle is in each quadrant. That's your reference angle. You're going to see a couple things that are true about the reference angle as we move on. But let's look at this first problem here. Now, if we're in quadrant 2, I know for a fact that my sine is going to be a positive value because my sine is my y value. I know that my cosine is going to be a negative value because my cosine is my x value. And I know that my tangent is going to be also a negative because tangent is y over x. You're dividing the two. And if you're dividing two different signs, it's going to be a negative. So right now, if I'm looking at those things, the biggest mistakes I see is students, they can solve it. You can get all the right fractions, but then you forget to put the negative sign, or you put a negative when you weren't supposed to. That's a wrong answer. It's even though you're super close, and maybe you got 3/5 and you forgot to put negative 3/5, still wrong because negative 3/5 and positive 3/5 are on completely different sides of the number line. You can't say they're equal. So you got to be careful. Now we do know that this going this direction is negative, so that's a negative 3. We know going up is a positive, so that's 4. We could find our hypotenuse. Negative 3 squared plus 4 squared equals c squared. I really don't need to do negative 3 squared because when you square a negative, it's going to come out positive anyways. So really, I could still just do 3 squared plus 4 squared. But either way, you're going to get c as 5 when you solve that. So my hypotenuse is going to be a 5. Now I know my sine of theta. Opposite is a 4, and hypotenuse is 5. It's going to be 4/5. My cosine, this is where it gets tricky. The cosine is the bottom number. It's the adjacent, but it's a negative. Cosine is negative 3 over 5. Cosine in quadrant 2 is negative. Your tangent of theta is your opposite 4 over your adjacent negative 3. So your tangent is negative 4/3. Now, you could leave the negative on the bottom, or you can just put negative out in front of the fraction. They're both the same. Either way, if one of them's negative, it's a negative fraction. So that is your first example there. So if it's in quadrant 2, you've got a positive sine, a negative cosine, and a negative tan. A lot of this is just looking at the clues. It's like you're a mystery solver and you're trying to figure out, okay, what quadrant do I put this triangle in? Which ones are going to be positive? Which ones are going to be negative inside the quadrant? So you're trying to solve a mystery. They give you clues. The clue here is, first off, the tangent's a negative value. Okay, so if you know tangent's negative, then you can narrow it down to 2 quadrants because everything's positive in 1, so it's definitely not here. And then in quadrant 3, they're both negative, and negative divided by negative is a positive. So we basically narrow it down now to either 2 or 4. So that we know. We also know that our opposite side is going to be -5, or a 5. We don't know if it's negative, because the negative might be down with the 4. But we just know that our opposite's going to be a 5, and we know our adjacent is going to be a 4, because tan means opposite over adjacent, TOA, T-O-A. We also know that our cosine is greater than 0, means it's positive. So we got to have a negative tan, and we got to have a positive cosine. A positive cosine means positive x. So that means it's got to go to the right. So we have one quadrant that we haven't crossed out to the right, and that's quadrant 4. So I know now that my opposite side is going to be going down 5, and my adjacent is going to be a positive 4. So I'm going to have an adjacent side of 4 and an opposite that's going to go down 5. So there's my 4, there's my -5, and I connect those to make my right triangle, and it's always connected from the origin. There's your right angle. This would be your normal angle, but we want the reference angle. We want that little theta right there. That's going to help us do the right triangle. Now to solve for sine and secant. Sine and secant is what we want. So to do that, we need the hypotenuse. So let's solve for hypotenuse. 4 squared plus 5 squared equals c squared. I can do -5 squared, but either way I'm going to get positive 25 when I square it. So I'm just going to do 16 plus 25. That's going to give me 41. And when I square root both sides, you're going to get radical 41 for your, radical 41 is your hypotenuse. So using the little clues that we've got our triangle now. The clues gave us the quadrant. It gave us 2 of the sides. So now I can use those 2 sides to find my hypotenuse. Now I can use that to find sine. So we want sine of theta. Sine of theta is the opposite side, which is a -5, over a hypotenuse, which is radical 41. So -5 over radical 41. Now we can't leave that radical down there, so let's move it to the top. So you're going to have -5 radical 41 over 41. Now I know that's messy and ugly looking, but it's exact. It's the exact value. If you want to make it a decimal, it'll look a lot nicer, but it will be rounded, and it's okay if you want to round that. But if they're asking for an exact answer, that's what you'd put. Secant of theta is best to just write down what 2 sides you need for secant. Secant is reciprocal to cosine. So cosine is cos, C-A-H, it would be A over H for cosine. But if you flip that over, it's H over A. So secant is your hypotenuse over your adjacent. It's exact reciprocal of what cosine would be. And so our hypotenuse is radical 41. And it is over the adjacent of positive 4. So did you notice that the cosine was a positive value up here? Cosine was positive. That means secant's also positive, because secant and cosine are reciprocal. They're the same sign. You just flip them over. Reciprocal doesn't change the sign. So those would be your 2 answers. The next one, they just kind of threw in what we call the axis angles. 0 degrees or 0 radians, pi over 2 is 90, pi is 180, 3 pi over 2 is 270. So what I would do here is I would put the coordinate next to each one. To get 0 degrees, you're over 1 and up 0. That's just the x-axis. To get pi over 2 radians, you go straight up. That'd be at the point 0, 1. And cosine is left -1 and up 0. That's at 180 degrees. And the coordinate at 270 is to go over 0 and down 1. Your cosine is your x value. And these are the axis angles, we call them. So your cosine is your x value. So cosine here is a 1. Cosine here is a 0. Cosine here is a -1. Cosine here is a 0. And you can see that right on your chart. You can see those right on your unit circle. If you look at your unit circle, you'll see the coordinates. You'll see over here to the right where 0 radians is, it says the point 1, 0, and it says cosine above the 1. You'll also see it on the chart. Go down the cosine column. It starts at a 1, goes to 0, goes to -1, goes to 0. So 1, 0, -1, 0. Tangent, however, tangent is your y value divided by your x value. So your y value is 0, your x value is 1. That's just going to be a 0. Second one, though, is a 1 divided by 0, and you can't divide by 0, so that's undefined. Cosine of pi would be 0 divided by -1, which is 0 again. And your y value in the last one is a -1, so if you divide that by 0, again, it's undefined. So they just wanted you to practice the axis angles, where you have the whole number of zeros and ones here. So those are right on your chart and right on your unit circle. So if you get something like that on a test, you can just go straight to your unit circle or chart. Those are right there. Just know that cosine is your x value, sine is your y value. Okay, moving back to this one. This is where I want to teach you about reference angles. There are two things that you have to know to be true about them. Reference angle is what makes our triangle, is the angle that makes our triangle. So look at this first one here. We kind of did one like this on number 1 in our notes. But this right here, you could bring a line straight down. So this is your reference angle right there, theta prime we call it. Theta is your angle that gets you there from 0. What we want to know is that what's going to make our right triangle, because we want the trig functions. So we need to find out that angle that's in here that's going to make it a right angle. Okay, so if it was in quadrant 3, it would be coming up like this. That would be your theta prime. If it was down in quadrant 4, it would be coming back up like this. This would be your theta prime. We want to find the right angles to our right triangles. So there's two things that are true about a reference angle. One is they have to be acute. You can't get sine, cosine, and tangent if they're obtuse. No SOHCAHTOA for obtuse. We have to use a lot of sines and cosines in that case. So they have to be acute and they have to be positive. So those two things have to be true about our reference angles. If one of them is not true, then your answer is wrong. Keep in mind, those two things have to be true. Okay, so let's see how we would get this one. If our angle is in quadrant 2, we're going to take the whole total of 180, where it would be the half circle, and we're going to subtract our theta from it to see what's left over. Or you could do pi minus theta if it's in radians. So that's a good way to get your reference angle. But one thing you have to know is, to be true, you always must, that's probably a double whammy there, always a must, I guess, but always must subtract. If you ever add, then you're going to be breaking your rules, because it won't be acute, it'll be obtuse. So you have to subtract. Okay, must be subtracting to get your answer. If you're doing the one in quadrant 3 here, then you're going to take the whole angle itself and subtract the 180 this time, because the 180 would be smaller, because your angle already passed the 180. So you want to know what's going to take me back up to 180, so I need to take my angle, subtract the 180 from it to see what's left. Or you could take the angle itself and you could subtract pi if it's in radians. But again, the key, must subtract. You cannot add. If you add, you're going to be getting an obtuse angle. And then the last one, it's almost a full circle. So you're going to want to do 360 minus whatever theta is. 360 minus the theta is going to give you what's left over. Or you could say 2 pi minus theta if you're using radians. But again, the key for these guys, must subtract. You cannot add. If you're adding them, it's going to give you an obtuse angle. So let's look at our examples. 300 degrees. Where would 300 degrees be located? Which picture is going to be like 300 degrees? probably like this one down here. It's probably going to be about this area, 300. So we're going to take the 360 and minus the 300 from it. So for this first answer, 360 minus 300, your reference angle is 60 degrees. 360 minus the 300 would give 60 degrees would be left over. It's positive, it's acute, it works. Letter B, 2.3. Where is 2.3 located? 2.3. Where would that be located? 2.3. Not first quadrant. It's not degrees. It does not say degrees. It's 2.3 radians. Remember, 1 radian is about 60 degrees, or 57.3. 1 radian. So that's 1. 2 radians is going to be about here. So 2.3 radians is probably going to be about there, because this is 3.14 radians, right? That's the half circle. That's pi radians. So we're looking at quadrant 2 for that one. So we're looking at the one similar to this right here. So what we want to do is take 180. In this case, we want to use pi. So we're going to take pi and subtract 2.3, but we're going to change pi into 3.14. So 3.14 subtract 2.3. Okay, 3.14 minus 2.3, you get 0.84. 0.84 radians. Is that positive? Yes. Is it acute? 1 radian is only 57 degrees, so 0.84 is less than 57 degrees, so yeah, it's definitely acute. So it does work for our reference angle. It is a positive and it is acute. But here's where it gets tricky. What if we're using negative angles? Now let me show you something. This is something I would highly recommend you do on your chart, especially if you want to add those extra credit points to your unit circle project. What I would highly recommend is you know how they number down the page in positives? I would number up the page in negatives. That would be something you would add to your project. If you 360, if you start at 0 at the bottom, you know how they went at the top? They went 0, 30, 30, 45, 60. I'd go 0, negative 30, negative 45, negative 60, and bring in all your negative coterminal angles. That will really help you visualize where those negatives go. I would also do it in radians. They start at 0, pi over 6, pi over 4, pi over 3. I'd go 0, negative pi over 6, negative pi over 4, negative pi over 3. And I work my way all the way up in negatives, because that'll help you see where negative 135 is located. Negative 135 would be at, see, positive with negative 135 is going to be at like at the 225 area. It's going to be in quadrant 3. Okay, it's going to be in quadrant 3, so it would be like in this area down here. So normally we would do our angle minus 180. Okay, but if I do my angle negative 135 minus 180, then it's going to break both of my rules. Because if there's 2 negatives, I would add and keep it negative, and it can't be negative. And B, if I added those 2, it's going to be a really big reflex angle. So what was my key word there? You always must subtract. So to subtract these, you're going to need to change your 180 to a positive. So if your angle was negative, then your 180 is going to be positive so that you can subtract them. That's why I put you must subtract. That is going to give you a 45-degree reference angle. Okay, so it's positive, it's acute. It's got to be positive, it's got to be acute. You must subtract to get it. If you don't subtract, it won't work. If you add, it's going to be obtuse, and it's not going to work. So it's got to be acute, got to be positive. You must subtract to get reference angles. All right, let's see if they gave us enough clues to figure this one out. They're telling us it's in quadrant 2. So I'm not going to actually use this chart. I'm going to make a new one over here without the X and Y, without the numbers. They want us to draw it in quadrant 2. Okay, so that's a good hint. And sine gives me my opposite side, and it gives me my hypotenuse. So I know that if I was to start at my origin, that my hypotenuse is going to be a 3. My opposite side is going to be a 1. So it's going to be a triangle similar to that. It's going to have a hypotenuse of 3, an opposite of 1, and it's going to have a right angle here. And I know I can find my bottom side by doing 1 squared plus x squared equals 3 squared, which is going to be 1 plus x squared equals 9. X squared is going to equal 8, square root it. You could use radical 8, but I would prefer 2 radical 2 because there's a 4 that can come out of 8. Radical 8 is not wrong. It's still an exact answer. And it's not a very big radical, so it's not a huge thing to have to reduce. But I would prefer 2 radical 2. What I see a lot of mistakes on is that they just put 2 radical 2 in the triangle and they think they got it. What I see a lot of students doing, they're like, oh, cool, I got my third side. There it is, 2 radical 2. They just made a colossal mistake. What did they forget? What direction are they going? Going left. What is left? Negative. They don't put a negative 2 radical 2 there. Now they're going to get the cosine and the tangents all wrong because they don't have that negative side. If you're going left, it's a negative. That's a negative side there on the bottom. Because you're in quadrant 2, you've got to have a negative cosine. You've got to have a negative tangent if you're in quadrant 2. Now what they're asking us for is cosine and tan. So yeah, they're going to both be negative. So cosine of theta is going to be the opposite side, or the adjacent side, negative 2 radical 2 over the hypotenuse of 3. That you can't reduce. So that one's already done. The tangent of theta, however, is going to be your opposite side 1 over negative 2 radical 2. You got to get rid of that radical from the bottom. So I would just multiply by the radical. So that's going to give you a 1 times a radical 2 on top, which is just radical 2. The bottom, these 2 radical 2's make a 2. So you've got negative 2 times positive 2, which is a negative 4 on the bottom. You could leave it with a radical 2 over negative 4, or you could just put the negative sign in front and then put radical 2 over 4. Whichever way you prefer to write your fraction is fine. They're both right. So that was your tangent. So you found the triangle, you located the third side, you put it in the right quadrant, you got the right opposite, the right hypotenuse, found the adjacent side, made sure it was negative because it's in quadrant 2, and then found your other trig functions. The last 2, I believe, are mostly chart and calculator ones. So let's look at this one. This one would be on your chart. I would just go straight to the chart and go down to 4 pi over 3 radians. So look at the radian column. 4 pi over 3 radians is at the 240 degrees, and it's asking for cosine. So I go over 2 columns, and it's negative a half. So that one would just be one to practice. You could have found that on your unit circle as well. Found out where 4 pi over 3 radians is in the third quadrant, and look for your x value, which is negative a half. Cosecant 11 pi over 4, I would subtract 2 pi from it. I would subtract 2 pi because right now we can't find it on our chart. I would change 2 pi to a pi over 4 so it's got a common denominator. So now I want to find 3 pi over 4 because these two are called coterminal. They have the same sine, cosine, and tan. Because they're the exact same angle, they're just a different rotation. So I want to look for 3 pi over 4 on my chart. If I go down the radians, 3 pi over 4 is at 135, and I go all the way over to cosecant, it's a positive radical 2. So my answer to that one is just radical 2. And if you had numbered up the bottom as negatives, negative 0, negative 30, negative 45, then you get a negative 210 at 150. 150 would be your negative 210. You go to tangent, negative radical 3 over 3 is your tangent value. So this is going to be negative radical 3 over 3. If you look at it on your chart or even on the unit circle, negative 210, negative 180, negative 210 would be 30 more. It's right there. tangent negative radical 3 over 3. The last three they want on your calculator. They want to make sure you can get these. I would practice and make sure you get these right every time. Easy problems to get. You don't have to show any work for it. You're just plugging them in. The first one, you're going to want to check your calculator and make sure you got degree mode. Because the first one's degrees, the other two are not. So go to your calculator, check for degree mode. I need to put mine in degree mode. And then cotangent, I'm simply going to put in 1 divided by tan of 410. I have to put in 1 first because I need cotan. And cotan button's not there, so its reciprocal function would be 1 divided by tan. And I put 410, and it equals 0.8391 when you round it off. So your answer here, 0.8391. Letter B, now you got to change your mode to radians. So you're going to slide it over to radians, hit equals, or if you're on your phone, just hit the radian button at the bottom left corner. You're going to need to put it in radians. Now, do you know what negative 7 radians looks like on the circle? Can you picture negative 7 radians? Think about negative 7 radians. Where would that be located? Think about the circle. Let me grab my circle here. Negative radians. Negative is downward. So we're going down negative 7. Would it be just barely in this quadrant in here, or are we going to keep moving? Negative 7. Isn't one full circle negative 6.28? So negative 7 is in the 4th quadrant. It's a little bit past that. So negative 7 radians is in quadrant 4. That means this answer better be negative, because you're in quadrant 4, and that's going to be a negative answer. So hit the sign button, and then hit the negative. Oops, not two negatives. Hit the negative, and then hit 7. So you got to have sign negative 7 inside equals. You get negative 0.6570 when you round it off. Negative 0.6570. This one you can put in 1 divided by cosine, and you can put pi divided by 9 in your calculator, just like that. 1 divided by, hit the cosine button, and then put pi divided by 9 into parentheses, equals 1.0642. 1.0642 when you round it off. So that is 1.4 notes and examples.